We're going to continue the discussion we started in class last week on solving logarithmic equations. Unfortunately, what I didn't want to happen happened, and school got canceled because of the weather, but I have no control of that, even though you're celebrating. So we'll do this now from the comfort of your homes. So remember, a log equation are statements that look like these, where we have either log or ln. And there are two ways to go about solving log equations. This is the first method that we're going to look at. And in this method, the form of the equation, as I said last week, looks like this, where we have a statement involving a log or ln, and then on one side of the equation, we have this C here, which stands for a constant or a number that we'll see. And what we're going to be able to do solving this method is we're just going to take this log statement and we're going to write it in terms of an exponential statement. So as a review here, if we have log, in this case, base b, we don't know what the base b, of some quantity is equal to c, we can rewrite that in the exponential form, base b to the c, and this c, this number that we see on one side of the equation, is our exponent in our exponential statement. And now this is going to be equal to our quantity m. And then we're going to be able to proceed from here to solve our equation. So we did the first two examples last week. So now we'll finish up with this example here. In this example, we see that we have not only one, but two log statements here. We have logx plus logx minus 3. And we know from our properties of logs that we're able to clean this up and rewrite this statement using one log expression. So when we're solving equations with logs, if we have more than one log statement, what we're always going to have to do is clean up the equation first using the properties of logarithms till we get one log or ln statement, and then we can go ahead and solve the equation. So addition, we know that that means multiplication. So when we put these together, we have log, and now we have x times x minus 3 is equal to 1. So let's continue with our multiplication now. Log, x times x is x squared, x times negative 3 is negative 3x, is equal to 1. So far we haven't really done anything in terms of solving it, but we have taken our two log statements and written it as 1. Now, when we look at this equation that we need to solve, this number here, this one represents our exponent. We have to apply that exponent to our base. We don't see a base written here, so this is where we have to recognize log with no specific number written in means base 10. So this equation can be rewritten in exponential form as 10 to the first is equal to x squared minus 3x. 10 to the first is 10. So we have 10 is equal to x squared minus 3x. Now, recognizing we have a quadratic equation, we need to see a 0 on one side. So let's rewrite this as x squared minus 3x minus 10 is equal to 0. I subtracted 10 from both sides to get x squared minus 3x minus 10 and just flipped it because I like to have my 0 on the right for whatever peculiar reason. Now we can go ahead and solve this. In this case, we are going to be able to solve it by factoring. And our two factors are going to be x minus 5 and x plus 2 equal 0. Each of these becomes a little mini equation. So we have x minus 5 equals 0, x plus 2 equals 0, x is equal to 5, and x is equal to negative 2. So quadratic, two answers. We have to remember, and I know this feels kind of like a gotcha because we did nothing wrong algebraically here to get these two answers. However, we might have to exclude one of these because the domain of logarithmic functions is restricted and goes usually from 0 to positive infinity, we have to check our two answers here and make sure that they don't create any situation where we're looking to take the log function of a negative quantity. So let's take the 5. If we go back in our original equation, log 5, we're perfectly good there. Next one, log x minus 3. 5 minus 3 is 2. Log of 2, we're good. So this equation here of x is, this solution here of x equals 5 is good. X equals negative 2. Just being that x equals negative 2, suspect that it's going to be a problem. Let's take a look. Log x, log minus 2, we can't do that. So we don't even need to bother here, because at this step we can see we can't use this solution of negative 2. So we reject that one and we don't use it, and our answer for this equation would be x equals 5.